Hello.
Oh, you have a question, Emil?
I
Hello.
do. Actually, it's more of a suggestion than anything.
Yeah, Philip, I hear you. Okay, go ahead, Emil.
Um, I sorry. I rather be humble up front
Yeah.
and be pretend to be cool.
Yeah.
Explain it to me like I'm five.
Okay.
That's the only advice I'm gonna give.
Yep. Yep. Yeah. And you
Sorry, if
guys,
that makes me look like an idiot, so be it.
Nope.
But I'd rather be humble.
right? So if you guys have any questions, be sure to stop me. I am shooting from the hip here, so I did not prepare a ton other than
Hello?
writing up the cards. Hey, Philip, I can hear you. Yep.
Hello.
Yep.
Yes.
So I'm going to just start and interrupt me if you guys have questions or you need me to clarify. And we'll just start charging through this. I'm going to start from the beginning. This one will probably be maybe one of the longer meetings. Use cases tend to be shorter, but the entity, well, let's start. Let me share my screen. And we're going to talk about entities. Entities are the heart of our domain, of our, oh yeah, go ahead, Emil.
So, just a quick question: is this more of a lecture series, or is this like an open-ended conversation? Because, like, sorry, I hate to be that guy, but I'm a learner that by asking questions in the middle of stuff.
Yeah,
So I know you said like I just don't want to be annoying, but also I want to learn as much as I can.
yeah, yeah. What was your question again? It was, is this a lecture or is this more of an open-ended discussion? It's an open-ended discussion. Yeah. This is just us talking about stuff. Yep. So I'm going to go to Confluence. I'm going to pull up the a document. Where is my space? I'm going to go to App Developers. And there's a diagram in here I like that helps describe our world. And it is right here. This diagram is a generalization of all the important things you're going to see in our app. And what you'll notice is this is the actor, this is the user over here. And everything feeds out to the user. This is the view coming out, and the user interacts with the everything else, right? We're here to present things to the user and accept input from the user. But notice the flow of this path. The arrows roughly flow like this, right? The user interacts. Usually that's with React or Babylon or something. They click a button. That input is often picked up by a controller. That controller typically calls a use case. The use case works on the entities. The entities update a presentation manager, which forms a view model, which then tells the view what it should look like. That is, in broad terms, our cycle of life in our app. And so the entity is deep down inside. This is the turning point. Everything revolves around the entity. It is our source of truth. These tend to be classes. They tend to be, we pass them around a lot. You're going to see this thing called entity context everywhere. And that is what we're working on. So we're working on the source of truth for our thing. And there's a lot of entities in the project. So now let me jump over here. I'm going to jump to the board. I'm going to pick off. I'm going to show you guys my flow for working with a card. We're going to do this pick entity challenge, this card. So pick challenge entity. I'm going to go and throw this in the to-do. I'm going to come in here. I'm going to, oh no, this card is different. Configure, what happened? I usually have branches and stuff in here. Oh wait, maybe it's collapsed. Let's go to details. Here we go. It's under details. It got collapsed. I'm going to create a branch. So this is my workflow. I'm going to pick off this card. I'm going to create a branch. This is a Git branch in the repo around this card for this effort. You can see I just do a quick check. Sometimes these repositories get changed, so I'm checking mine. It is the hotspot. The type I'm going to do is a feature. And I want to come off of develop. So those are my setups. I click this button. We get going. It's going to take a second, and it'll form a branch for me in Git. And I'm going to click this little copy button right here. That copies my little Git checkout. Let me flip over to my project. You do a Git fetch. That'll pull in that new branch. It'll make a reference to that branch. And then I copy and paste my entity, and now I am in that hot. You can see down here in the bottom, this is my branch here. Feature, hot app, 49, pick entity challenge, pick challenge entity. So show me I'm in my right branch. All right, I'm going to close out all these things. Close everything. Close all. Let's get back to the basics. Now, let's go back and look at this card. So let me go to my card again. Where is my card? Here we go. So this is the way I do my cards. You'll see this a lot. Let's just take a quick look at this card. I try to always link to the Confluence page where this is described. So if we click on this, this will take you to the Confluence page where we talk about how this thing fits, how this particular effort fits into here. And in particular, we're working on this one. And now we can read through this. This I tend to copy and paste directly into the card. So this is what we're working on, pick challenge entity. You can see my card is in progress. Let's go back to that card and just look at it. Where are we at? Here we are. All right. We're going to create a new observable entity called pick challenge that holds the data for the pick challenge. This is a feature we're adding, a pick challenge. And this is a challenge. You guys can read that document. All it is it's like a quiz we're going to present to the student that says, hey, pick on this hotspot that does this. And the student is going to click in the world, in our scene, and they're either going to get it right or they're going to get it wrong. We're building out the source of truth for that particular system, that pick challenge. It will need to support the following properties. And so we'll, I needed to change this. This has changed, but we're going to do, all right, so we're going to ask the student to pick on a hotspot. Well, we have to know which one is the correct one, right? That's part of the data we need to know. We need to know is that, because you can imagine they're going to click, we're going to get that ID, and we got to know, is that right or is that wrong? So that's where that correct ID is coming in. This has changed. I forgot to update it in here, but we're going to just support one correct ID instead of an array of correct IDs. So change that real quick. Then there's this function called isCorrect. We need to let the author tell us which one is correct. So this is going to set isCorrect, get feedback, set feedback. All this stuff is defined in here. So it's all defined for us. So we got a nice starting spot. So let's just get going. So I'm going to kind of bring this up. I'm going to move this onto a different screen. Let's get out of full screen here. I don't know how I got into that. I'm going to move that over here. And I'll be referencing this guy once in a while. All right, so first things first, we are building an entity. So we jump into our entities folder. These are all the current entities that are in here in this current app. And then a key thing here is this entity context. You guys are going to start becoming very familiar. This is an interface that we pass around to the whole system. This is our nugget of the state of our app is held in here. We instantiate this once in main, and we pass it around, and everybody works on these entities. This is our source of truth for the entities. And so you can see all the entities we have in here. And we're going to be adding another one in here called pick challenge. So let's go ahead and start building that. So first thing coming into here is I go to pick challenge.ts, and right away, I'm test-driven. You guys are going to learn this. I'm a Nazi when it comes to test-driven development. Pick challenge.test.ts. So every source should have right next to it a test that tests it. All right. So let's get going. I can see. Okay, we're going to start getting into some kind of complicated object-oriented patterns here. And we can dive into details as to why we do these, but just hang with me for a second, how we build out an entity. Well, actually, let me show you one. What we do, let me find one that's already working. This is our app state. This is an entity that's alive. And just the patterns I want you to notice here. First off, these upper two, these are just enums and an options list. These are just defining an enum. This is key. This is the actual app state entity. But notice it is an abstract class. So we use an abstract class, and it extends a base class called observable entity. Let's take these things in steps. Observable entity. This is coming in from this package. This is our package. We own this package. This is at VivEd. This is an NPM package. You'll notice it's an app package. We build a lot of common code that we're going to use in all of our apps. We put it into an NPM package and we just have to install it. And it's coming from the entities folder. So that's appropriate. We are in an entity, so we can import other entities, going back to our graph that talks about the rules. So we're bringing in this observable entity. What this thing does is it allows this thing to follow an observer pattern. This observable entity, let me just go to the definition, see if we can see it. What it does is it adds these functions to this class for you. You don't have to do it. Other scripts can become an observer of this class. So essentially, this will become important when the views and the presentation managers come in particular. Presentation managers, they need to be notified whenever something changes in this class. So we use a notification, observer pattern. So other scripts can add themselves as an observer, and they can remove themselves when they're no longer needed. And then there's this notify function that gets called whenever we need to notify everybody. So that's what the observer entity gives us. It's very simple, not much going on. All it's taking care of is these observers. It's managing your observers for you, so you don't have to write it. And we just did this because we were writing these exact same functions into every single entity. And we're like, you know what? Let's make this into a base class. So this app state extends observable entity. That sets up our observer pattern already. And then later down here, you'll see these we can call notify when things change. Okay, next thing, abstract class. So this is a little bit of a advanced topic. We're dealing with an abstract class. What that means is, notice this is exported. We're exporting the abstract class. Down here is the actual implementation of the class. This is where we actually wrote the code. You can see it's called app state, same thing as up here, imp. It's the implementation of app state. But notice it is not exported. This class is not accessible by anybody outside of this script. What we're doing is we're creating a very strong contract with the rest of the world as to what you can access. So we know this is clearly defining, all right, these are the things you can do with this class. And it keeps us from, it gives us some advantages. This is object-oriented kind of best practices. It gives us some advantages. Essentially, everything outside of this class is programmed against this abstract class. Oh yeah, go ahead.
Quick question.
Yeah.
Sorry, once again, explain to me like I'm 5.
Yeah.
So I love this. I love this idea, but this is actually kind of a new concept to me, what you're introducing right here.
Yep.
So how is this like traditionally in React, right? Export, right?
Yep.
We would export it, and we would only import it into scripts that we would be using the functionality of that class or something.
Yeah.
So why is it beneficial to limit what is exported through another section?
Yes. So outside of this class, everybody that imports, everybody that references, everybody that calls this, they're calling, the name they're using is this. This is the word they use. Import app state, right? And then they hit appstate.slideText to do the slide text, the gets and the sets, right? But behind the scenes, this is where we hook it up. This is actually the logic of that. Now what this does is this allows us to modify this. We could run into cases when you really find this with testing, and you'll find this a lot more with mocking. So this isn't a super good example, but particularly it allows us to hot swap what is actually going on with the app state on runtime without anybody else changing. So you can see this is app state imp. Let's say for some reason we had a different app state we wanted to use. Maybe I'm just going to use a totally strained example here that doesn't make a lot of sense. But let's say we want to use this app state imp when we're running in North America, and we want to use this app state, a different app state imp for some reason when we're running in South America. It does.
It allows
us to swap it at runtime, the actual implementation of the app state. So it really decouples. It's a strong architectural boundary is the technical word we're using. Creates a very strong architectural boundary between entities and the other layers. Okay?
And so therefore, like in the big picture, you only have to export
app state.
For example, app state.
Yeah.
But the code of the class app state inf automatically creates an if state. Like, I'm sorry to use such a simple idea, but it creates a switch or an if statement that allows it to limit what app state is depending on its usage with another code.
Yes, it allows us to change the app state implementation at runtime if we need to. Like, let's say we pick up, let's say you set your language to Spanish, and something in here was involved with that. We could swap out the implementation of app state at runtime. Even after we instantiate, we could swap it out hot, where you click a button and boom, we swap out that app state to another implementation and we're good to go. So, yeah. It also gives us there's a lot more like subtle details. It gives us a lot of flexibility, and it gives us a very, very strong contract. And so what I mean by that is, as you're developing this, let's say you accidentally put something like, a parameter called something like some number equals 5. All right. So you've done that. Now, if this was the exported class, you might have just inadvertently leaked out this parameter. And you don't know, because this is public. This is implied public. You now don't know other people now have permission to access this thing, right? And so we don't have such a strong contract with the rest of the world at this point. So this creates a very clear agreement on what this entity is able to do. Okay.
Perfect. Sorry.
Yep.
Just for my own edification.
Yep.
And ego.
Yeah.
Do you understand why I would ask that question of like why go
for sure.
Extra step when there already is a structure in the framework for it?
Yep, 100%. It took us a while to get our heads wrapped around why this pattern is valuable. Like, this was not intuitive. Like, this was not our first entity was not this, right? And we just learned over time that we want to protect our entities, and we want a strong. Our entities are our holy grail too. So we want very, very stable entities, because if you remember that diagram of all the circles, changes ripple.
Value, entity,
use
cases.
Yep. Changes ripple out. So instability ripples out. So this is really close to the core. Value objects are more of a special case. They're core, but this entity we want this thing to be stable and bulletproof. That's our goal. We want this guy to be as strong and, resilient as possible, because any weakness in this ripples out and affects everything else. So that's why we do this.
Sorry to get super nerdy here, but just is this classical architecture at this point, or is this something that's company dependent, that it's kind of avant-garde that you guys have developed?
No, this is a kind of a basic object-oriented programming. In object-oriented programming, it's best practice to, and I can reference a book for this too. It's best practice to code against abstract classes, and if you can, and it gives you just a lot of flexibility. And you'll see this even more when we get into testing and when we get into injecting and stuff like that. So, yep. All right. So we got our abstract definition. Oh yeah, go ahead. Yeah, go ahead.
So I think this clean code architecture is very similar to MVC pattern. So I think this entity is very similar to model. What do you think about it?
Yes, it is. It is very similar to like in an MVC architecture, model view controller architecture. This would be the model. Yep. Yeah.
Oh,
Yep.
great. I see. Okay, that sounds great.
Yep.
Thank you.
Yeah, you'll see some patterns that are really. We started out MVC, Model View Controller architecture, and so you'll see that this is kind of a expansion on Model View Controller. Okay, so we've got our abstract class, observable entity. Next thing we do is, since the implementation is private, we have to get this out. So notice we use a factory. This is a factory pattern. You're going to hear factory patterns a lot. It's called make app state. And the key here is, one, it's strongly typed to return the app state, right? But what it actually instantiates is the implementation. So let me just do a quick example just to kind of iterate home. Imp2, let's say we had two imps in here, right? App state 1, imp 1, and app state 2, imp 2. And here our factory, we had some sort of condition. And this is a bool. I don't know what it is. Just an example. Now what you can see is we could say if condition return this app state, right? Else return the imp state 2. All right, this is just a strained example, but this is what we could do, where when we make the app state, we can decide at runtime, because this is going to get called at runtime, we pass in this bool. Do we want 1 or do we want 2? So we could say use 1. We can pass this in and dynamically flip. Are we doing this imp, which would have different code, or this imp, right? And everybody else does not care. Everybody outside of this script is not affected. They're all using this. They're all pointed at this guy. So there's an example of a semi-practical use of this pattern. All right, let me discard that, and we'll start building ours. All right, let's get back to ours. So here we go. Let me put, I don't want to be in this. I want to be here. And we're going to do test-driven development on this, of course, because we are good programmers. High quality around here. All right, so let's start this. I'm going to do export abstract class. We're going to call this pick challenge, ENGE, and this is going to extend observable entity.
Observable entity.
Yes. And that gives us our notification system. Let me take a moment and let's see. You don't always need to use an observable entity. Most of the time you do, but sometimes you're going to write entities that maybe they don't change. Maybe they're like a configuration that we set up at the beginning and we just expect it not to change. We just it's going to get set. You don't need to observe it. We just read it, right? It's just a source of truth on a configuration or something. But a lot of times you do observable entities.
Oh, I see.
Yep. Another thing to point out is you'll see these, just a quick sidebar on patterns a little bit. If you see repo, so this is a hotspot repo. Repo is short for repository. What this suggests to you is that this is the list of a lot of hotspots. So there's hotspots, and then there's a repo. And that kind of suggests to you that we don't know how many hotspots are going to be there. Those hotspots are created and destroyed as life goes through. But that list of hotspots, that ownership is managed by the repo. So when you see a repo, you'll almost always see a thing like a hotspot repo and a hotspot. You might see scene object repo, that's meshes in the world, the things you see, the meshes, and scene objects, So just a little pattern that you'll start seeing. All right, but this is not going to use a repo. This is going to be instantiated, and it's going to be doing its thing. All right, let's start with, so we do this. I'm going to just bring this over real quick. We're going to pick one of these easy ones to go with. We're going to go with, let's start with this, correct ID. Again, this is not supposed to be an array. So we have this, we're going to use an ID to identify which hotspot is correct. So let's start with that one. So we know there's gonna, since this is we know this needs to be an abstract. All your parameters in an abstract class need to be abstract as well, which means you have to define them in your implementation. So we're gonna do abstract. We're gonna do getters and setters. You'll see I do getters and setters a lot. And that's because we need to notify when it's set. So we need to do a little bit of checking and stuff like that. So we're going to do a getter and a setter for this this parameter. So we're going to do a get, and it's called correct ID. That's a string, but it can be undefined, because if there are no hotspots in the scene, or the user has not set this, we don't have it, right? There's a moment where we don't know which one is correct. So we got to do that. Oh, we need a little bracket after this. We're going to do a get. We're going to do and we're going to do an abstract set, correct. And we're going to do a val, which is a string, or undefined. These have to match because it's a getter setter. So this and this have to match. Let's just put this as ID. All right, we're going to start here. Now, let's go ahead and let's do our class pick challenge imp. This is our implementation. And this is going to extend the pick challenge. All right. It's going to say, oh, there's some problems. I'm just going to implement the inherited classes. Little shortcut, command period will get you a little thing. And so now you can see this was filled out for me because I'm extending, and it knew these, and it said, okay, so this is the contract. I have to do this, or if I don't have this in, you'll see I'll get a compilation error up here. Well, I should. It's not working. It's slow. But anyways, we have to do this. All right, and let's go ahead and set up our factory, and then we can start writing tests. So we're going to export make pick challenge. This is going to return the abstract class, but we're going to make a return new pick challenge imp. So we returned our implementation. Why are you not happy? Why is this grayed out? I feel like
line 5, perhaps. Not to be. Is your get set up correctly?
I think so. I feel like sometimes my VS Code, I think it's acting funny. Give me a second. I'm going to just kill it and bring it back in. Sometimes VS Code gets a little monkey. Let's do this again. I'm doing a. What was that, Philip?
Your background is great.
Oh yeah. All right, I think we got it. I think we'll give it a second. I'm doing screen recording. I'm doing shared screen. I'm doing Slack. I'm asking a lot of my old computer. So I think we got it now. All right, good. So test-driven development. We have set this thing up, but we have not really done any logic yet. We're set up, and we don't do logic yet until we write a failing code. So let's jump over here to our code. We're going to do, this is the pattern you're going to see me do all the time. I always start out with a function called make test rig. This is our setup. This is what we do every week. I call this on every test. And what we're going to do is we're all these tests, we're going to need our pick challenge. Oh, I don't want that to be caps. I want that to be lower. And so this is going to be, oh, it is. I'm still, something's wrong. All right, so we're going to be a pain. Pick challenge imp. Let's, come on. What's going on here? Return new pick challenge. Pick challenge. This extends that. Export. Why is this the wrong color? Looks. Oh, for the love of Pete! Why has it got to fight me?
Function. Use function. you have visited the function.
Oh, yes, yes. Export function. There we go. Good call, good call. There we go, there we go. All right, now we're working. Yep. All right, so let's make that. So we're going to make our imp. All right, so this should, and it's going to need to import it. So there we go. There we go. So this is our first one. Again, forgot the function keyword.
Yes.
There we go. There we go. Now, I know this has an observer pattern in it, so I'm going to go ahead and set up my observer. And that'll come into play in a little bit. So let me show you how I test observers. We do a constant observer equals just a simple jest function. All right? This is a generic thing that you can use for testing. It's a jest function. So jest is our testing, our unit test, and this allows you to do it. And now we can do it. We can add this as an observer. So we can do pick challenge dot add observer observer. Now this is what we'll use to check to see if the observer is getting called when we change things. We'll get to that in a minute. So now let's do a return pick challenge, and we're going to return these two things. All right, that's our test rig. This is our setup. We're going to do this on every test. Now let's set up our test. I like to wrap my tests in a describe. So we're going to do this thing called pick challenge. And we're going to do an it. I like to use the it keyword. You can also do test here, but I like it because it sets up this sentence really well. And I'll show you why these things, why we tend to do these. These are not like breaker rules. It's just, I'll show you why we do this. Okay, first thing we want to do, it sets the correct ID. Easy peasy, easy test. So now let me get down here. We're going to do an npm test, and we're going to grab this one. We're just going to test this one script like this, and we'll get this going. And the reason why I wrap these in the describe and the it is in a second. We'll see it down here. Get it going. My tests are going to be slow because we're running so much. Okay, so I just want you to see how this looks in the console. So here's what we're going to see. Okay, so these are our test suite. The pick challenge entity. This is showing up and it's indented like this because we put it in this describe and we use this. So when you're seeing a whole pile of tests, this formats it nicely so when one of them does fail, it's easier to like kind of find it. And then you can kind of read it when you use the it keyword and you combine that with that sentence, it sets the correct ID. It just reads nice in here. Pick challenge entity sets the correct ID. All right. So that's the reason why I do that. We do our constant. We wrapped it. We're going to spread out the make test rig. So we call the test rig, and we're just going to get our pick challenge. And what we're going to do is we're going to expect. I'm going to do a little test at the beginning. I expect pick challenge dot correct ID to be undefined at the beginning. Right? That makes sense. That's what I would expect.
Yes, you're right.
Yeah. So notice how the programming is working. I'm over here. This is test-driven development. I'm over here thinking, what do I want this code to do? I'm not actually doing it. I'm over here saying, all right, I think the code should start out undefined. Then I'm going to do a pick challenge dot correct ID is going to equal some ID. Then I expect pick challenge dot correct ID to equal some ID, right? There's my first test. All right, now this should pass. This should fail, right? Because we don't have any code in here. All right, so you can see we're throwing an error. Great, we're failing. That's what we want. We write a test that fails. Now we jump over here, and let's make this thing work. All right, so. Okay, so now I'm going to start out simple. You only write the code to make this thing pass. We have a getter setter, so we need a private correct ID string undefined equals undefined to store this thing. So actually, let's just start out before we do this, I actually maybe jumped the gun a little bit. Let's do one line. We should expect this to come back as undefined. This is going to fail, right? Because we haven't set it up. So I do a private correct ID is undefined. So now we're going to return this dot correct ID. All right, that should. Is that going to pass?
Oh, no. You go
Oh!
to the set-
Yep. Good call. Let's see. Yeah, right. This should be here. Return this dot correct ID. There we go. Oops, there we go. Let's pick this
Yes,
up.
you're
There we
right.
go.
Great.
There we go. Now this should pass. All right, let's uncomment out this. Right? Now this is going to fail. So now we do this. This dot correct ID is equal to ID. Excellent. All right, let's add another test. It should notify observers when the correct ID is set. All right.
Yes, you're right.
So I'm going to grab this again, and we're going to do observer. And now what I'm going to do is I'm going to just say pick challenge correct ID equals some ID, and I expect the observer to be called. So this is that observer pattern. Essentially, you know, we want to notify the whoever, we don't know who's watching, but we expect that when this changes, we notify those guys. Hey, something changed over here.
Oh,
That's what's going on. Okay? So now what we need to do is when we set the correct ID, we need to do this dot notify. That notify comes from our observable entity extension.
oh.
So that's going to notify. So anytime the correct ID gets set, we tell all the observers, hey, something changed. Check it out. They do whatever they need to do. We don't do anything after that. We just let everybody know the correct ID has been set, right? Well, let's add another test.
Yes.
It only notifies if the correct ID changes. So essentially, as we're building this out, we don't know what those observers are going to do. So now watch this. Let me set this up. So we're going to set this. Now what I'm going to do is this. I'm going to do observer. This is a jest function, so we can do a mock clear. And what that does is it kind of resets that observer. Then I'm going to do this. 1, 2, 3. It's the same thing. We should be smarter. We should not, you know, even though somebody is setting that, we should expect the observer not to be called, right? We don't know what notifications are, what those observers are going to do. So we want to be careful about broadcasting changes. These could have costly effects. We don't want to, so we want to be like, did it really change or did somebody just set it? So we're checking. So now what we need to do is we want to say, okay, if ID is equal to this dot correct ID, return, right? This is going to bump us out.
Yes.
Right. So good. This is going to do it. Now, that should pass. There we go. There's our tests. That is test-driven development, right? Now let's take a moment and we can make this a little better. This pattern that you see right here, when we're setting a parameter, we're checking for changes, and then we notify if changes have happened. We do this all the time. This is very, very common in Entity. So what we did was, I'm going to refactor this. And so, because I know that we have a tool, we have a little script we can use to make this a little bit easier. But notice when I refactor, I don't need to change my tests. These tests describe the expected functionality of this guy. When you refactor, all the tests should still pass. So let me show you my test, or a way we can refactor. We're going to do a private thing called a memoized correct ID. Now what this is a new memoized string.
Memory string.
Yeah.
Memory is a string.
So I'm going to, oh, wait, no, we can't do it. Never mind. I can't. So a memoized string is a string. This little guy just holds a string, and whenever you set it, it checks for that change, and it'll notify for you if a change is detected. So all this checking and all that stuff, it takes care of it. But I just remembered we can be undefined, and this memoized string won't support that. So never mind. We're not going to do that. We're going to call this one good. Let's move on. Next, so now I'm going to reference here my card again. I'm going to go back to here because when you guys send this pull request to me, I'm going to run through this card. And for all these things that I see, I'm going to see if there's a test that's checking to see if it does what the card says it's supposed to do. That's my number one thing I'm going to do is I'm going to be like, all right, can you prove that this will notify, all that stuff? So the next one, we're going to check to see if something is correct. So this is a function that returns if a particular hotspot is correct. All right, so let's write that test. So let's get over here. Oh, we have to extend this first. So we're going to do abstract is correct. We're going to pass in an ID, which is a string, and we're going to return a bool. This is just going to say, hey, is this ID correct? Somebody else is going to use this to check. All right, so now you can see our imp is giving us an error because we're not satisfying our contract. So let me just implement this class, and we'll throw it down here. And before we start writing code, we write tests over here. So it returns true if when checking for the correct hotspot. There's a better way to say this. Returns true if the ID matches the correct hotspot. All right. So what we're going to do here now is we're going to grab this. I'm just going to grab this thing. We don't need our observer. Now, what we're going to do is we expect pick challenge is correct. Some ID to equal true. That's what we expect to happen, right? Pretty easy, straightforward. The implementation of this is probably very easy. It's going to be if ID equals this dot correct ID, return. Actually, yeah, we just do. Actually, what we can do is we could just do return this. There we go. Yep. And so let's go ahead, just be thorough. Now, as a developer, you're like, all right, you're thinking, as you're working through this, you're going to see all the edge cases. You're going to see the ways this can go wrong. I can immediately say, well, what happens if the correct ID is undefined? I guess they won't equal, but let's prove it. Let's prove it. Let's be thorough, right? It returns false if the correct ID has not been set. So let's just make sure, let's dot our I's, cross our T's, and just, make this thing bulletproof. This should return a false. And we probably don't have to do anything for this. And then the other thing we're thinking of is, all right, we should probably check to make sure this returns false so they don't equal. Because essentially we don't know, we should not make assumptions about, somebody could come along and refactor this code over here. We just want to check everything. We're checking everything. So it doesn't take long, right? It returns, I spelled that wrong, false. If the correct ID does not match. So this one we're going to pass in this correct ID. And we're going to say some other ID. All right. There. We have fully encapsulated the functionality we expect. Like, it is fully tested. Somebody could come over here and do some refactoring, renaming, do whatever they want to this. And we have covered all of our cases, all of our edge cases, right? And we've proven it. We have unit tests that run. This is bulletproof at this point. And so that's what we're shooting for. All right. Now, here we go. Okay. This is wrong. I've refactored. So I originally was thinking we were going to do an array of correct IDs. So I was thinking we could do more. You could have multiple IDs be correct. But I decided not to support that. So some of this is out of date. So we're going to take this out. We don't need that anymore. That was a mistake on my part. All right, the other thing we're going to deal with is we want feedback. So the author is going to be able to. So imagine this. Imagine that the game we're playing, you're asked to click on something, and these things are glowing in the scene. When you click on something, we know one thing already: is it right or is it wrong? And then also, we're going to provide feedback, right? So the author can set it up and say, all right, if the user clicks on this one, provide this feedback. Maybe they want to give them a hint, say, oh, try this, or that's not right because of this. Or they might say that is correct, they want to provide feedback. So every hotspot in our scene can have feedback. So what do we want to do? We've got this get feedback for a hotspot. That's going to return. And we've got this set feedback for the hotspot. So let's start with set feedback, because you can't really test get feedback until we have some feedback. So we're going to start with this one. We're going to start here, set feedback. So let's go ahead. What time we got? We got 9 more minutes. But I think we've gotten a lot of this. You guys are seeing the patterns here. We're going to do abstract set feedback for hotspot, and this is going to return a void. Actually, is it going to return a void? Yes, we're going to return a void. Set feedback for hotspot. All right, let's go ahead and get this guy to compile by throwing in this kind of stubbed in guy. Move it down there. All right, first thing we do, it sets. We're going to have to do both of these because how are we going to check it? It sets feedback for a hotspot. Let's go ahead and do this. So we're going to do this. Pick challenge dot set feedback for hotspot. We're going to do the ID of the hotspot is hotspot ID, and the feedback is some feedback. Now, I'm guessing, this might fail. Yep, this is going to error out because we're throwing an error, which is good. All right, so let's get this one to pass. First thing we need to do is, all right, so I see this as probably a map is what I would imagine we do here. So we're going to do a private feedback lookup equals new map string. And let me know if you guys need clarity on what a map is. It's a lookup table. So now what we're going to do here is we're going to do feedback lookup dot set. Oh, we needed this. Dot feedback lookup set ID feedback. All right. That should pass at that point. Now we should check to see if it set it. So now we need to do the get feedback. So let's go ahead and stub that in. Abstract get feedback for hotspot. This is going to return we pass in the ID. So this is the ID of the hotspot we want. In fact, let's make this a little more clear. And then let's make this hotspot. All right. And this is going to return a string, but it could also return undefined, because what if we haven't put anything in there? So we could have an undefined. So there we go. So now let's add this. Throw this down here, down at the bottom. And here we go. So now we expect pick challenge dot get feedback for hotspot with this hotspot. What do we got? What's it called? Hotspot ID. To equal some feedback. There we go. Now, here we go. So now we're going to just return this dot feedback lookup. Nope. Feedback lookup get hotspot ID. There we go. That should pass. There we go. Now, let's be thorough. It returns undefined if we get the feedback for an unknown. Let me check something. I'm checking my document. Oh, no. So I'm checking my document. What we said here is if no feedback has been set for this hotspot, return an empty string, not undefined. So let's fix that up. So this should be always going to return a string. Now, let's change this, get. And now we're going to do we have to do a little bit of checking here to get this to compile. If this dot feedback loop has hotspot ID, we're going to do this. Oh, come here, you. All right, still doesn't like that. Okay, let's do this. I got it. Here, we'll do this. Constant feedback is going to equal this. And now that could come back as undefined. So now what we could do is we could say return feedback question that. So this is just going to check for it to be undefined. Now let's just write a test. It returns an empty string for the if the feedback has not been set. All right, so now we do this. Grab this guy again. And we're not going to set it. And we expect this to be empty. All right, see if that works. So we're going to start to run out of time, but you guys can kind of start seeing the pattern here. The key here is notice that the rhythm and the way we do test-driven development, it just naturally builds out a really good documentation about what this script is supposed to do. When I hand this off to you guys, when we pull out ZSpace, whatever this is, you guys, if you guys need to come in here and refactor ZSpace, you could start reading this. You're like, okay, it does not, it's supposed to notify when the render flag changes. There's a test that proves that. It allows an observer to be removed. Okay. It notifies when the device list is set. So you guys, from other people all working together, it's a really good, it's our living documentation about what this script was intended to do. So that's the beauty. And then, also as you guys get in here and you start debugging where there's a bug floating around, what you guys will end up doing is you'll form a hypothesis. You'll say, okay, I think this bug is because we're not notifying when this thing changes, or we're not catching this condition. First thing you do is you write a test to prove that fails like you think it does. And then you correct it. So, and then, it's all set up and ready to go. And, just a living document. and we're running unit tests on this guy, and everything is charging. All right, we're going to go ahead and take a minute there and stop on this. I think what we'll do is we will, I'll try to finish this out real quick so that we can move on to the use cases, because the use case works on this. So I'll take about 10 minutes. I'll knock this out, and you guys can read these things. At this point, this is kind of the end of our discussion about entities. Last little thing. Okay, let me show you one last thing. Since we've got this thing working, last thing we do is we add it to the entity use case. So up here, entity context. I'm sorry, we'll add it to the entity context. It doesn't matter where let's just throw it right here at the end. We're going to do this pick challenge, and that's a pick challenge type. And then we add it down here, pick challenge, is we're going to do a make pick challenge. All right. So again, our entity context is defined with this interface. So this is just an interface, kind of like an abstract thing. And it's created by this function, by a factory. And this is created, when we start the sim. So let me go to find all references. You'll see, oh wait, there's a lot of these because we're using it in test. You'll see the main place we make it is right here in main. When we start, first thing we do on our constructor is we make our entity context, and then you guys are going to see this entity context everywhere. It's getting passed around, and everybody works on that entity context, and that is our source. All right. Any questions before we take a break? Yes.
When will you be publishing this, or are you comfortable if I try to remake this exact video to learn as best I can?
Yeah, I'll do that.
From a fire suit, bro.
Yeah,
so I'm just trying to keep up.
Yeah, for sure. Let me show you something. If you guys are interested, I don't know which one of you is going to get to it first, but after watching this video, you guys should be comfortable, or at least feel like you can give anything with an entity in it a shot. So here, there is one right here. Refactor app state entity. Essentially, we're going to add an enum and a get setter to the app state entity. We just need to add it. It already exists. So all you got to do is set this up, write this using test-driven development, and it should notify whenever something changes. So that same pattern you saw me do with the string, we're going to do it with this app mode in this thing. So this entity this card is ready to go. Unfortunately, this is the only other entity card available right now until I start the new feature documentation. But in the next video, we're going to get into use cases, and there is a lot of work to be done on use cases. And so if you guys want to fight over who does the entity, the other guy gets to do use cases, and you both will be working on use cases by the end of the day. Okay, so yeah, Emil, if you want to just redo that card, essentially what I would recommend you do is pop out a feature branch, or just branch, and then you can look at that card that I was working on, this pick challenge entity, and then you can just submit a pull request to me at the end. And we may not merge it. We may merge it, and then I can review it at least, and we can talk about it.
Okay.
All right. Great, guys. Well, let's take, let's see. Let me check the calendar real quick. What is the next meeting? I think it's in 15 minutes, maybe. I put little breaks in here. Yeah. Okay. In about 10 to 15 minutes, we'll meet again, and we'll start on use cases. Use cases are a lot easier. A lot less complicated stuff going on. All right, guys.
Yep.
I'll see you guys in a little bit.
Thanks for your.
Yep.
Yeah.
Yep.
Thank you very